So the ventricles in that second phase of diastole, when you have that passive ventricular filling, so they're just going to be opening up on their own, and some blood's going to come in, and then the atria are going to contract, and that pumps it up all the way.
Okay.
So it is going to wait till the ventricles have opened up.
And is that
then
why
atrial
the
pump it
AV
through.
node like pauses it? Just
Exactly.
waiting for it to fill? Okay.
Exactly, because, well, and then so the other part is, yeah, because the atria contract, pump out the ventricles,
Yeah.
then the ventricles contract after that valve's been closed. If we do it both at the same time, really what's the point of having atria? Because it's just an open channel, open system anyway, and it doesn't really.
And then it goes from there to the lungs, back in to the left atrium, left ventricle, and then out.
Good.
Okay.
So the pause, that's so that the atria can contract. Right?
That's so that the atria contract, and then the ventricles have a chance to fill, be totally full, and then they'll contract. So we want the atria to contract just before the ventricles.
Okay.
We don't, if they all contract at the same time,
Would be
those ventricles don't fill up as much, and there's just no point.
Where does it go through like the bundle of his and Purkinje fibers and stuff?
Where does it go?
Like when, I guess.
When? So, let's draw a heart. Not a perfect heart, but it'll be a heart nonetheless. So we have two atria and two ventricles, right? Ventricles, atria, more or less. Here's your valves. Okay, so then we have SA node. Wow, that one's right. AV node. And we have the bundle of His, and that's where it crosses that line between atria and ventricles.
Mm-hmm.
And then you have your bundle branches. There's actually more than that, but there's one more, but I got it. And then you have, Purkinje fibers coming off of here. Anyway, you get the picture. Okay? So, SA node depolarizes, right? That signal travels through the atrial muscle. So all the atria are going to contract, hits the AV node, we get that pause. So now that blood's filled up these ventricles. Then the AV node sends its signal through the bundle of His, bundle branches. Basically, once it hits the apex, that's when everything starts contracting.
Okay.
We kind of get this bottom-up contraction. I mean, it's so fast, really, it's all the same, but kind of a bottom-up contraction so that the blood gets forced upwards through those valves, the semilunar valves.
So does it just go to that side and then it waits to go to the right atrium? Does the right side of the Purkinje fibers, or is it just all at once?
It's all at once. So all the atria are going to depolarize at the same time. Then it'll pause at the AV node, and then all the ventricles depolarize at the same time.
But I thought the right ventricle, and then through the lungs, and then the left atrium, and then the left ventricles.
That is the way that the blood flows, but in reality, blood's flowing from the right atria to the right ventricle and the left atria to the left ventricle at the same time. So, I mean, if we were to track a single red blood
No, 'cause
cell,
it's continually
it would
flowing.
flow that direction, right?
Okay.
But in reality, we're pumping both at the same time.
Yeah, because it's always flowing through. Okay.
Right.
So when it hits the AV node and it pauses for a second, that's when there's the plateau phase with the calcium? Or is this something different?
That's a little different, really, because what we're looking at with that is like an individual cell.
Okay.
We're looking at one cell. So that plateau phase is there so that action potential can get throughout the entire atria. So every single cell depolarizes. If it was a really quick depolarization, there's a chance that some of that sodium may not be able to get over to the cells around it, and so it wouldn't depolarize. And so you'd have the atria contract, and then like a couple random cells over here contract, instead of everything going at once.
Okay.
So doesn't it the signal travel fastest through Purkinje fibers? Or is that not true?
Well, yeah, it's gonna travel faster through all these fibers, period. And that's why we have them. Because really, if you think about it, we really technically don't need any of this nervous tissue down here. Because cardiac muscle can conduct its own action potentials, right? There's gap junctions, intercalated disc and branch fibers down here. So really, our heart the signal could be conducted without this nervous tissue.
It speeds it up.
But it speeds it up and makes the whole thing more uniform, so it all contracts together. And like I said, the idea is we want bottom-up depolarization rather than top-down. If we contract from the top down, the valves are up here, we're kind of pushing the blood somewhat away from the valves rather than